We'll be doing some multiple choice questions based on escape velocity. The first question I'll read. Escape velocity of a rocket from Earth is 11.2 km per second. I hope you remember this number. We had just now calculated in the previous module. What is the question is, what is the value on a planet whose acceleration due to gravity, small g, is double that on the Earth and diameter of that planet is twice that of Earth? So in this case, you know what is the formula for escape velocity in terms of acceleration due to gravity, because the conditions are in terms of acceleration due to gravity. So you know VE is always given as root of 2g into r, right? So I can say in this case, let's say the ratio of the escape velocities for planet Earth and that second planet be taken as V1 and V2 respectively, then V1 upon V2 is equal to. Now on the other side, when I take the ratio of square root of 2gr, let us assume the acceleration due to gravity of planet Earth be g1 and that of other planet be g2. But for the other planet, they are saying the acceleration due to gravity is double that of Earth. So I can write as 2 times g1. Similarly, if I consider the radius of the planet Earth as r1, then the planet which is considered in the second option, its radius would be twice that of Earth. So it is 2 times r1. So if I substitute these numbers inside the square root, I get square root of 2g1 into r1 upon 2 into 2 times g1 into 2 times r1. So cancelling 2 g1 and r1, I get finally v1 upon v2 is equal to root of half into half, that is nothing but square root of 1 by 4. That is nothing but v1 upon v2 is equal to 1 by 2, where v1 is the escape velocity of Earth and v2 is the escape velocity of that planet which is to be found out. So I want to find out v2. So just rearranging, I get v2 is equal to 2 times v1. And in this case, what is v1? They've given us escape velocity from Earth is 11.2 kilometer per second. So substituting that over here, I get 2 into 11.2, that is nothing but equal to 22.4 kilometer per second. And this is your escape velocity for that second planet. Option is second option B. Let's see one more question. The ratio of the radii of planets P1 and P2 is K. The ratio of the acceleration due to gravity, that is small g, on them is r. Then the ratio of the escape velocity will be how much? So now here again also escape velocity in terms of small g, you know, root of 2gr is the fundamental formula I am going to use. But then before that, let us assume the radius of the planet P1 as r1. Let the radius of planet P2 be r2. Let acceleration due to gravity of that first planet P1 be taken as g1 and acceleration due to gravity of that second planet P2 be taken as g2. Okay. They have given us the ratio of the radii of these two planets, means r1 upon r2 is k. So remember this, r1 upon r2 is k. I will require it later. Also, they have given us the ratio of the acceleration due to gravity of these two planets is small r. So remember this also, I will require small g1 upon g2 is equal to small r. Okay? Now we start with the question. The ratio of escape velocity. What is the formula for escape velocity in terms of small g? In terms of capital G, you remember it is root of 2gm upon r. You know, small g is gm upon r square. So in this case, if I substitute in place of capital GM, gr square, I finally get the formula for escape velocity as root of 2gr. Now, in this case, let's say the escape velocities of planet 1 and planet 2 be taken as VE1 and VE2 respectively. Then their ratios will be equal to root of 2g1 into r1 upon 2g2 into r2. Cancelling 2. Finally, I get VE1 upon VE2 is equal to root of g1 upon g2 into r1 upon r2. Now, you remember r1 upon r2? that ratio is given in the question. It is given as K. And you also remember the ratio of the acceleration due to gravity, G1 upon G2, that is given as small r. So substitute this K and R in the expression, you will get your answer. So it becomes VE1 upon VE2 is equal to root of K into R. And as per that, your answer will be option number C. Clear?